Good day, guys. How are you doing today? Today we continue our lecture on where we stopped in the previous class. In the previous class, we talked about some questions we can integrate using C++ as well. But now we're going to be going to the exposition of C++ over inheritance, polymorphism, and encapsulation. Let's go through the slide together. Inheritance is a fundamental OOP mechanism where a derived class like new, like a child class, a derived class, or a child class. What do you mean by a derived class? Before we can have a derived class, that means there must be a base class or a superclass. Other classes make use of superclasses like Java, but also have base classes or a parent classes. We can also use another word for derived class as what? Derived class can be in form of what? Child class or derived classes. So now, so they can acquire the derived class, any derived class that is inheriting some things from properties from the parent class must have something you want to inherit from through the behaviors of the existing classes. For example, a child can inherit from his parent, either from the mother or from the dad. So it's also the same thing. A vehicle, we have vehicles, we have cars, we have lorry, they have some form of functionalities. We can apply brake, they can also start as well. So they have some common properties and they have different things that make them different. So now the same way also in some situation, the purpose of having inheritance is to reduce code use, one, to modularize our code, two, to avoid too much code. Inheriting, since the same thing has already existed, you can easily manipulate what you have. So that is the essence of having inheritance. Instead of us redesign the wheel again, you can easily have it in one place and also just inherit some properties or common features of the other class. Now, let's say for usability, logical structure, the core benefit of polymorphism that enables dynamic behavior as well. It also enables us for what polymorphisms. That means something appearing in more than one forms can appear in this form. Then if we implement something for animal, for example, if you implement all the properties of a car, or for example, for a car, let me use a car, then you can see some function, maybe for 2-door car, or for 4-door cars, for 5G, or so 6-plug vehicle, or 8-plug vehicle, depending on the task you want to carry out. So the C has some properties, you just implement and change, call the same function and change and override what is there before. Then let's see a sample of inheritance. How do we do that? In an inheritance, we assume we have a base class. A base class, this is the derived class. It can inherit all the properties, functions of the superclass that the derived class. So, then for example, let's consider a base class here. For instance, we have a vehicle here as a base class. We have some public here. That will be public or protected. Some access specifier that enable us to access. We cannot make them private. So we'll be able to access them. Can make it public or protected. Then you can also have some properties like string. You can see in our encapsulation before, we do make them what? And maybe some things we use before in some other previous classes. We make use of what we call string and properties called private or access specifier. So down here we are making public or either protected. Here we have the brand of a vehicle. This is the brand. We already have one properties here. One property is the brand. The vehicle is the constructor that is taking in a reference to be now. Now let's have a constant here of the brand. We use an initializer list method to assign a value of this, to get the reference of this to this. Then instead of us saying brand equal to this, you can say brand into parentheses B. Then we also start an engine. Every vehicles, you can start the engine, whether motorcycle, whether car, you can start the engine, you can stop the engine. So you can also display information about that vehicle or that motorcycle. It's also part of vehicle, right? So all those machines have their properties, their display information about them. Then we can now implement this for a car. Now we can and remember we have a vehicle declared here as a superclass, as a base class. Then we can, this is the derived class called car. Derived car here is called a car. Then we can easily get what? The properties. How many number for int number of doors? Here we can see maybe it's 2 or 4 doors. Then number of doors. Yeah, but the door here was not specified here. But this is properties here now. Properties here. Then you can easily get, okay, this is a car taking into constructors here. Doesn't mean you can also have constructor for the derived class as well. By the time you search the constructor, so you can also supply in some values there. Then we also avoid onc. Can you see? Constant, car is on, beep, beep, on. So it's on. Can see on. Display car information. This is what? This is coming from the what? Information. You can also see override what is inside here and add some other information there. But this one, this display car information is coming from the what? Base class information due to the public we are able to access it here as shown. Remember, we said that our car here is private by default, but here is public. We have to make it public when we are what? Inheriting the properties functions. Then you can also what? You can now instantiate the car here, the number of, so once you instantiate the car, my car, you create my car from derived class. Then you can, my car can start the engine, my car can honk, also my car can also display information of that car. Yeah, you see, you can see start the engine. Do we have start engine here? No, we don't have start engine here, but it by default it will start, it will call the one in the base class. So once it is we call this one, so it will automatically apply for the derived class. So it was able to inherit the functions of the super class or the base class. Then let's move to inheritance. It's supported in several forms. Inheritance for flexible class design. Single, you can also have single inheritance, multiple inheritance as well. You can also have multiple inheritance by just separating with comma. So instead of this having only one single inheritance here, like public vehicle here, you can just have double inheritance. Let me see. I'm looking for the class. Okay. You can also have another one comma here and also add other classes you want to what if it is multiple inheritance you want to do. Also have hierarchical inheritance. So a class, a multiple inheritance derive 2 or more base classes. 2 or more base classes. Class amphibious vehicle, public land vehicle, because maybe class amphibious vehicle is the name of this class with derived class. Is land vehicle. It's derived from this, and water vehicle. It's also what deriving from this. So we have 2. That's this one, the derived class. This is 2 base class as well. So challenge, ambiguity, e.g. diamond problem. Often ambiguity of name, we also have ambiguity, something appearing in many forms. So you can also use what we call the scope resolution method, of course, the namespace, or use virtual inheritance as well to do that. Let's see type of inheritance in action here. We have ng. We have a class called ng. We have also another class called the GPS. Right? Maybe you want to track the GPS. Some class has GPS. It's not all the class that has GPS. Right? Every class has an ng. Then let's see a smart car. A smart car should be able to have GPS, right? Then we should have an engine inherited from the engine, the GPS as well. And so you can see multiple inheritance in action. Then you can be able to what? To locate, start every engine you have to start. Right? You have to start the engine. Can you see a function call from the engine? Start, common. So engine is common. They are the same scenario with what we have in the previous lecture, in the previous slide. You also have hierarchical inheritance. Multiple derived classes inherit from a single base classes. So multiple derived classes. So multiple derived classes or multiple charge classes can inherit from what? From one base classes or one super classes, one super class. So a shape can have, for example, now, maybe you have multiple level, you also have multi-level inheritor. Just follow the same thing. So you also get it on the slides, into bits. Let's see class of animal as well. Let's type of animal here. We have animal and we have mama. And so we also have class dog as well. Can you see? An animal here is animal, mama is inherited from animal and what? But level inheritance. And dog is inherited from what? From mama, a dog is inherited from mama. So all the features in one of those classes will be able to be accessed in those classes as well. You can see hybrid as well, the same thing. You can follow it. So let's see the word interfacing. We also have, but there's no interface keyword like that as is appeared in Java and C# or in Golang as appear in C++. But we achieve it through the use of abstract classes, through the use of virtual method, and the abstract method through the use of virtual method. So an interface defines a contract of capabilities, a set of public methods that class must provide without specifying the implementation. So why do we, there's a difference between the use of inheritance and a use of interfaces. Once you declare something as abstract or virtual method, pure virtual functions, by assigning it to a function without any implementation, you implement that, but it will be equal to 0. So that it will be equal to 0. That and all those functions that are equal to 0 must be implemented. You must the derived class must provide information about those things. Every one of the 80,000 of them, there must be an information about those 1,000 in the class that is inheriting those things. But if it is inheritance alone, you might choose to just pick 1 or 2 out of it. That's signified. But in interfaces, the same also in Java as well. You use implement for interfacing in Java, and also, but in inheritance you use extend keywords. That's in Java. Well, that means the same way it works as well. You have to provide all the information necessary. Whether you just declare them without putting information there, but the system must be able to see that somebody else is trying to implement that functions as well. Interfaces is via abstract classes. C++ implement interfaces using abstract-based classes. Let's see, for example, A, B, and C classes. And ABC is a class containing at least of pure virtual function classes. Can you see? Instead of that pure virtual classes, you assign it equal to 0. So this is what we want to accomplish, what interfaces here. So you can enable interfacing method through the use of abstract-based approach. Classes inheriting from A, B, and C must implement all. Can you see? Must make all these pure virtual functions. So unlike any time you just choose to inherit one or inherit anything from it, interesting. But for you to inherit for something, that means you've seen some things in it. Let's for example, let's have I. Sometimes you always signify by putting I in front of them as well. But put IO, that means this is what interfacing, for instance. Now let's see this example. Let's declare an interfacing here, a class called interfacing. Let's also, you have what? A public called virtual. This virtual, the virtual function here, can you see? Equal to 0. So, and this enables that this one will be automatically be free, be automatically be dynamic, be what? Be terminated, be free after will be released all the resources of garbage collection after the program terminated or is out of scope. Then you cannot inherit this now. Can you see? We have this serializable here, serialized here. So this is a user here now that want to serialize maybe user objects. Now you have the public is serializable, is the class here. We have a function. Since we have it here, we have to provide, we must call this function by all means and implement it. Implementing means provide information that you want it to do, then const override. You should override what is here. That's how interfaces is done in C++. We now provide the information, a function, constant, override what is in the word in the base class here. So then interfacing is via abstract class 4. Okay, still continue. So save data, Bob's days. So this approach allows function to operate in different type of polymorphic way. So appearing, you can also have, there are different ways of accomplishing polymorphism. We're using the use of what? Maybe you have compile type polymorphism, one-time polymorphism. So you can also achieve them. Or compile type polymorphism, they are at compile time. You can also do that. You can do compile type polymorphism through function overloading. The same function will get the same name, but the number of the signature may be different. The signature may be the number of say type return and the number of parameter that function receives. So that also have constructor overloading as well. The same constructor. Instead of has one constructor, you can have multiple constructor. So you can also achieve many true polymorphism as well, like compile time polymorphism. A virtual functions with no implementation is the base classes. So we don't implement it. for our. We also have the compile time polymorphism or runtime polymorphism. This is achieved through the use of what? Operator overloading. Operator overloading. You also seen in all of the slides I sent to you earlier. So let's see a sample of it here. Let's see a shape here. Let's call it a shape here now. Let's call it, we have a pure virtual function here. But see, you can also have join generic here. You are implementing, this is not a pure virtual function in its own places, its own case, but this is all a pure virtual function. This you are providing implementation for this virtual function here. So you can easily call this one, whether you call it or you don't call it, but this one, any function that inherits this must provide information about this one. So provide information about it. Now the circle that do this must what? Create a circle of this and then do the calculations as well. So see the rectangle as well, and then you can see you can run the code through, you get your results. Okay, now let's see shape 3. Okay, now let's move forward. Constructor and destructors. We talk about constructor. The constructor is just taking the name of the class as well, and then what the destructor is put the tilde sign. The tilde sign is the sign beside your keyboard by pressing the shift, command shift, or command the shift and the on your normal HP, your normal standard keyboard, be a key beside the one number key. You see the tilde sign and press the shift sign with the tilde logo. So and then you put it in front of it. Then let's see the constructor and destructor. So let's also have virtual destructor. Okay, see we see all virtual destructor the right time. Declare base that destructor virtual with this tilde sign. The tilde sign I'm talking about. This is the tilde sign here on your keyboard. It's always beside your one. So now, can you see this one? That ensure the virtual destructor enable that is called preventing resource leak. To what resource leak? That there won't be leak in your program, a memory leak in your program. Now let's see a sample. We have a base class here. So we have a base class. Okay, we also have a constructor here. Also have a virtual destruction here. This one to enable us to avoid memory leak as well in our code. It's called dynamically, automatically. So you can also see we implement that. We also have its own derived classes as well. So now let's see. You can go through them and run this code as well. We see an exercise. We're going to also have an exercise on this as well to be able to prove our point. So data abstraction and encapsulation. Now we have encapsulation. Encapsulation enables us to prove for security. All the properties as well is declared. All the properties is declared private, but the method alone is only made public for security reason, for you need to access that. But in our previous lecture, we said that friend functions can only break through encapsulation, and it is rarely used, and it's for some constantly sake, any sake that's for one reason important sake that we can only use the use of friend functions because it use breaks and encapsulation. So example of them also, you can see it also in Java, is the use of setter and getter approach method in Java. You select some getter and setter. A function will set the values, a function will receive the value. So the setter and getter approach. And see boundaries of object, data attributes, and methods. So the method that make public, while the attribute that make private. And this so let's see. Let's see an example of this here. Let's see an example of it. We have a thermometer. This is an example. Encapsulation continue. Okay, this is the abstraction. This understands abstraction. Okay. Can you see? Because they say under extra abstractions now. Now let's go to our information ID. You can go to the abstractions. That's what we'll be discussing before. You can see now. Let's go to information ID. We have the public. For public, it can be accessed anywhere outside of your program, but the private can only be accessed within that same class alone. Cannot even go out of that class. Any property that is declared private, any properties that is declared private cannot go out of that class. Then, benefit of encapsulations. For modularity, data integrity and security, and maintainability as well. You can change data state. You're going to see example of it. Let's illustrate this now. Let's change, instead of using public interfacing here, you can also use yours private. Change it to private. You cannot declare a port, and you see you now have a private here. All the parties here will be private. The function here will be only be make what public. So okay, I think we are through with the slide. So in our example, I'm going to demonstrate how you can use as encapsulation, also all those encapsulation, detailed security as well. Thank you very much. I think we have reached the end of the slide. Just like, share, subscribe. Have a nice time.